Okay, so looking at question 10 now, it says solve the simultaneous equation x minus 1 over y minus 2 equals 3, and we have x plus 6 over y minus 1 equals 4. And it asks us to not, so do not use trial and improvement, you must show your working. So bearing in mind the rules, if you like, the rules of answering this question. Now the question awards us with 5 marks. 5 marks for this question to find out the x and y values for which both of these equations are true. Okay, so if we crack on then straight away and we look at, we're going to label these 1 and 2. Okay, so we're going to label this one where we have x minus 1 over y minus 2 equals 3, and then we have over here equation 2, we have x plus 6 over y minus 1 equals 4. Okay, so we'll concentrate on part 1 here and we'll explain what we're going to be doing at each stage, and then we'll simplify and quickly complete part 2. So what we want to do first is we want to make sure everything is on the same level, if you like. So what I will do is multiply the denominator by y minus 2, which would mean I'd be multiplying this 3 by y minus 2 as well. So how we will write that: y minus 2, y minus 2. Essentially we're not multiplying the denominator, sorry, I mean we're multiplying the numerator so that the y minus 2 factor can cancel. Okay, like so. And then of course these will cancel, making x minus 1 equals 3 y minus 6. Okay, if we simplify that out. And now here we have, and we can put it in form, if you like, we can put it in terms of y. That doesn't sound like a bad idea. So we have, if we add 6 to both sides, we have x plus 5, and then because we still have the 3y, we divide by 3, like so. And that would be this, and that would be the entire thing here in terms of y on this side. So we have y equals mx plus c. This is the linear equation form. So we've done that on this side, but now we need to continue and do it this side. So I'll quickly go through that. Of course, doing it quickly. So we have x plus 6 is equal to 4y minus 4, and then we make in terms of y, so x plus 10 over 4 equal to y. Okay, so we've got 2 linear equations, right? So in order to solve these, we need to set them equal to each other, right? So we need to set them equal because essentially these 2 equations, 1 and 2, are the same. So when we were looking at the previous question where we were dealing with a line and we were dealing with a quadratic, we need to find out when they are both equal on the graph, okay? When they both intersect, in other words. Okay, so by doing that, we have them both in terms of y. So I'm going to use the method of substitution, substituting one into the other, or in fact just making them equal would be the better term. So a quarter, we'll just do that over here. A quarter x plus 10 is equal to a third times x plus 5, like so. Okay, so in order to get rid of the denominator, sorry, the quarter and the third, we multiply, if you like, by 3, multiply out by 4. We could even just times by 12, which is the common factor of both. So if we multiply by 12, we get 3 times x plus 10 equals 4 times x plus 5, and then simplify, 3x plus 30 is equal to 4x plus 20. And then making x the subject, so we're subtracting 3x from both sides, like so, gives us x plus 20 is equal to 30. What value of x would make this true? Well, x must then equal 10, right, in order for that to be true. So we have our value of x, okay? So now we need to find, again, our y value using what we've got here. So we're just going to get rid of a little bit of the workings out for the first linear equation. So if you don't mind me just getting rid of that, and then that as well. So using what we have down here where x equals 10, we're going to substitute that into linear equation 2 because of course we've just gotten rid of the first one. So substituting x equals 10 into there, y would equal a quarter times 10 plus 10. Well, y is equal to a quarter times 20 because 10 plus 10 is 20. Well, 5 4s go into 20, therefore 20 divided by 4 is 5. Therefore, when y equals 5, these two graphs, if you like, or these two lines intersect when x equals 10, y equals 5. So the coordinates, if you like, can be written like so. Therefore, we've solved the simultaneous equation. We've used two linear equations. We've used 1 and we've used 2. We've used both of these, set them both equal to y, and then we've just made them equal, solved for x, substituted our x to find our y, and there we go. We have 10 and 5, and this is our coordinate for the solution.